Hi. So in this video I'm going to be telling you about basic block diagram connections and their operations. Like I told you in the last video that I'm going to be telling you about some basic connections and their operations which will be helpful in block diagram reduction technique. This video you should look properly, watch out, because these results you should be knowing instantly. Like you should know by heart all these results, and whenever there is a need in reduction technique you should be knowing the outputs, what will be the equivalent and what will be the output. So I'll take the first connection, that is called series or cascade connection. Series or cascade connection means there will be two blocks one after the other in one path. This is called series connection. You have GS, value of this block, G2S is value of this block, XS is given as input, YS is given as output, G1S is KS is the output of G1S and XS. So this arrangement is equivalent to this value. XS is given to a block where the value of the block is G1S into G2S and the output will be YS. Then YS will be given as G1 G2 X. S I am skipping. This S I am skipping. Sorry. G1 G2 X. You can see this whole arrangement, only XS and YS are same, but this whole block from here to here is replaced by this block G1S into G2S. You can see here how this works. See, this is the block. So KS, my KS will be G1 of S into X of S, and this YS will be G2 of S into K of S. My K of S is nothing but G1 of S, X of S. See, this output and this output are same. So you can see there is no change. You are giving XS input, you are getting YS output. Here also same thing. The value of the YS is also same thing. So we can replace this whole arrangement from so this whole block, dotted lines I have shown, can be replaced with G1S and G2S block. Okay, so you should remember the results. If you have something in cascade, two blocks in cascade, you can replace by multiplying the gains, inside gain. Now look at the other connection. This is called parallel connection. See this way. You are giving input to here, this G1S block. You are giving input to G2S as well. You are getting output from both. You are summing both outputs and giving it to YS. This is my arrangement. This is called parallel connection. Remember this arrow sign. It is going from here to here, not here to here. Here to here it is going in forward direction. So when you will see, this is equivalent to a block G1S plus minus G2S. Here plus minus will lead to plus minus. Same X as YS, this whole big block is replaced by G1S plus minus G2S depending upon the signs, plus or minus. You can check again. This output will be G1 into X, this output will be G2 into X. Now if you will sum both, you will get G1 plus G2 X. Similarly here if you see plus minus, sorry, because this is plus minus. Similarly here if you will see ys is my g1 plus g2 x. So there is no change, means I can replace this block, full block, with this block. Okay, here it was multiply, here is what it is summation. Now look at the third arrangement. This example I used in the previous video. This is called feedback connection. See here when you saw the input is going from here to the G2 block and it was going to the summer. But here if you will see the input is from here, it goes to HS, then this output goes to summer. So it is in backward direction. This was in forward direction. This is in backward direction. That is why it is feedback. You are putting some value of output with a gain to the input. That is why it is called feedback. Here this is the input, this is the output, this is the gain block, this is the feedback block. Again you can replace it by xs is equal to xs ys, same, g1s divided by 1 plus minus gs hs. What I want you to see is if minus will be there, here plus sign will be there. If plus sign will be there, here minus sign will be there. So it is opposite. If there is plus minus sign, we will write g1s upon 1 plus gshs. If negative plus positive sign is there, then we will write 1 minus gshs. Okay, you can see it directly. I think I have solved this in the last video. You can cross check with the values. The transfer function was gs divided by 1, I guess, plus gshs, because we had minus there in the last video. Okay, so this is the basic block arrangement. You should be knowing this, and this will be helpful later on. Now what I want you to see is the next two arrangements. So here you can see this is a bit tricky one, so you should be following me carefully. We are shifting a summing point after the block. We want this summer to go from here to here after the block. What I have in this arrangement is RS is going to the summer, XS is going to the summer. My summer output will be RS plus XS, and this is a GS is a block, so YS will be multiplication of this and this whole. So my output is GS into RS plus XS. Now this block is equivalent to this block. See, I want this summer to be this side. So blindly what I'll do is I'll make a summer, I'll give output GS and input to the GS. This block arrangement will be same. Only thing I made changes, I put the summer here. Now I'll make the changes. See, you have to keep the outputs constant, means like you should not change the output. So you have YS here is equal to GSRS plus XS into GS. So here if you will see, RS will go into the GS, so my output will be RSGS. My YS is GSRS plus XSGS. I have RSGS. What I need is GSXS in summation. So what I'll do is I'll put a summer, and with summation I'll put a value XS into GS. I made this block, I gave a input XS, so that we'll get output this same. Here input was XS, RS, XS. So this whole big block from here to here, I can replace it with this whole big block, because RS XS was my input previously and output was YS. Same thing is here as well. So you can see the idea was I saw the output and I kept the output same, and I made the changes here accordingly. I hope you get this. Same thing, if I shift the summing point before the block, now instead of going here, I am going from here to here. So what I'll do is, blindly I'll make a summer here. I'll give an RS input, GS and YS will be there. So you can see this part I have normally. Now what I'll do is, I have RS will come from here. So RS will be here multiplied with GS will be here. So in output I will get GS into RS anyway. What I want is access. I don't have access and I have to go through this block as well. So what I'll do is, I'll put a summer input to the summer with 1 by G value, and the input to the 1 by G will be access. What will happen is, here we will get output RS plus 1 by G access. See, RS from here, access by G from here. Now when you will multiply this block to this whole term, you will get this value. You can cross check. So I had this output. I wanted to change this point and this summer to this point, so I blindly did this. What I had and what I want to have, accordingly I changed the block and the input. See, again RS was my input, access was my input, YS was my output. Same thing, access is my input, RS is my input, YS is my output. So this whole block is representing this whole block. This is a bit tricky, you should go through this again. The only thing I did is, I kept the output same, output from the branches same. That's it, nothing much. And accordingly I made changes here and I made change here. Now the next two rules connections are similar to this, but this time we are shifting the takeoff point. Here you should see this is my takeoff point. I want this to go here. Remember, this is coming out of axis. It means the takeoff point takes out something. Whereas when you had summer, axis was going inside. When you have takeoff point means it takes out some point. Since it is connected to axis, that is why this point is axis. Now what I have output is YS is equal to GS into axis, just a block. Now what is the equivalent to this? See, I want to shift this point to this point. That is why I'll blindly put access to GS and then one branch of takeoff point here and YS as same. Just like this arrangement. Now I'll cross check the outputs. See, YS is equal to GS into XS. Still I'm getting YS is equal to GS into XS. But when you will see this output, XS, it is coming out, that is why output. This is XS. Here also I want XS, but I don't have XS. This takeoff point will take YS out, since it is connected to YS, and my YS is GS into XS. So if I want XS, sorry, I lost focus I guess. Yeah, see, here you can see to this point, YS is coming out of this takeoff point. I want XS to come out. My YS is GS into XS. So what I'll do is, I'll put a block with 1 by G value and let this takeoff point go through that block so that I'll get XS at the output. See, that's what I did. I know that from there here YS is coming out and I need XS, so I put a block of 1 by GS to cancel this out so that ultimately I will get XS. See, I kept the constant. Here the output was same, so I don't have to worry, but here the output changed. That is why I have to make arrangements. See, XS was my input, XS was my input. Here takeoff point and YS was my output. takeoff point and ys is my output, same thing. So I replace this whole block with this block. Okay, now see the seventh one, shifting the takeoff point before the block. Now instead of going from here to here, we will go from here to here. See this arrangement. Again we have input, mark the inputs, outputs. Xs you have gs, so ys will be gs into xs. Here ys you are taking out of the from the takeoff point, so ys will be gx xs. Now when you will shift this point here, blindly you make xs a takeoff point coming out of this branch, gs and ys. You will see that ys will be same as this one, but here the takeoff point will take out xs, but I want xs into gs at the output. That is why I'll put a block of gs so that this xs will pass through this gs block and my output will be gs xs. So this last 4, 5, 6, 7, these 4 points you should be careful of. These are a bit tricky and you need design kind of thing. Just for your confidence, I'll do an example here. Let's say an example. So what we will do is, let's say we have a summer and this is going in x1 and this is going in x2, both are plus sign, and this will be my output, and let's say this is my takeoff point. Okay, so my output will be x1 plus x2, and since I am taking off this value, so here also it will be x1 plus x2. Now what will be my equivalent when you will take this takeoff point before the summer? So I want you to think about it and try it out for 5-10 minutes and pause the videos, and I will solve next. So meanwhile you can try. I'll autofocus. So I hope you tried. Now I'll work out the solution. Okay, so see, since this point I want this side, what I'll do is, first of all, I'll keep the input as it is, x1. I'll put a takeoff point here. I'll keep a summer here and I'll keep the output here. This I need from here to here. I wanted something, so I kept it. Now what you will see is this was my input, like this, x2 plus, and this is also plus. So the output x1 plus x2 still I am getting, but from here I am taking off x1 value. See, this takeoff point is connected to x1, that is why x1 is coming out, but what I need is, I need x1 plus x2. So what I'll do is, to make this equal to this value, I'll put a summer, I'll give this arrow plus, and I'll give x2 plus, so that my output will be x1 plus x2. So did you saw how I made this arrangement? I had this output same, so that is why I didn't do anything here. 1 minute. This focusing is a problem, I guess. I should do something about this, I guess. Anyway, so we have this block here. So you can see this summer I kept same, so that my output was same to the previous one, that is why I didn't do anything here. But my takeoff point output was x1 plus x2, but in this case I had x1 only, so I designed in such a way I gave x2 and I got x1 plus x2. So that is how you will do this summing or shifting takeoff point or anything you can do. Just you have to make sure that you will keep the output same. So for your example, you can try it out, like you keep this takeoff point here and you try to take this takeoff point to this place. What I did is from here to here, you should try it out from here to here. This I am giving input now like this. You have a takeoff point like this and you have an output like this, x1, x2, y. Let's say output. This is my x1. If I'll take this value to here, this point, takeoff point, what will be my answer? So you can try it out, this thing, if you are sure of. So I hope these are the basic block diagram connections. These two takeoff point, shifting before the block, after the block, shifting the summing points before the block, after the block, this connection of series cascade or parallel and feedback connection. You can see these things you should be knowing by heart, because these cases will be useful when we will reduce the block diagrams, big block diagrams, and there I will directly use the results. For your references, I'll be showing you these slides again and again, but my suggestion will be you should know, means like by heart you should know this stuff. Okay, so in the next video, what I'll do is I'll take a big block diagram and I will reduce using this small connections, and you will see how I will get a transfer function finally by reducing those big block diagrams using these small connections. So yeah, I'll work out an example in the next part.